One of the most useful tests that we could use for graphing polynomials of larger degree is going to be called your leading coefficient test. And what this tells you is that as x moves to the left or to the right, the graph eventually falls or rises. Since it is a continuous function and it's not going to be going vertical and it's not going to just stop, and it goes on forever, both towards negative infinity and positive infinity. The big thing to remember here is that when n is odd, you're going to have a couple different characteristics. So when n is odd, that means that your graph is going to look like a, what we call that, an x to the third here in this case, because you have two curves. And notice that it starts down here at the bottom on the left and it starts here on the top on the right when your x, or sorry, your a value, which is right in front of your first term, is positive. That means it's going to fall to the left and rise to the right. Now if your function is still odd, but your leading coefficient is not even, or a positive number, then that means that your graph is going to be doing something else. That means that it's going to be rising as you go to the left and going down and falling as you go to the right. So whenever your leading coefficient is negative, that means your graph rises to the left and falls to the right. So what we want to do is we're going to look at how you need to write your describe your end behaviors of your graph, because we did this back in Algebra 2, where when you look at the right side of each graph, and then you would write the right side of the graph like this. Notice in the two functions, even though they're opening up or going up in different directions, the one on the left still has the same format as the one on the right, because x is both going positive. If you look at as your graph goes to the left, notice that we're going to write these about the same no matter what. So what we need to do is we just need to find a template in order to write these. That would follow this graph, what it looks like here, where your a is positive. That means your graph is going to be falling to the left. So f of x approaches negative infinity as x approaches negative infinity, and then it rises to the right, which means that f of x approaches infinity as x approaches infinity. Okay, for example 2, when we want to describe the left-hand and right-hand behavior of the graph, what we want to do is we want to talk about what f of x does. Okay, so I like to leave a little blank here as x approaches negative infinity. I always like to do the left side first. And then we want to figure out what does your y do, your f of x, what's your function do as your graph approaches x to the positive infinity. So what we want to think about is, if we look at this problem here, we have where you have an odd degree, and then your a is positive. So when we're looking at that, we want to look at the problem on the left, where your graph is going to be falling as it goes to the left. So we're going to put in a negative infinity right here. And then as it goes to the right, where x is positive, then that means our graph is going to be going up. So that would follow. Okay, for example B, we're going to write the same thing. We're going to talk about what f of x does. It approaches blank as x approaches negative infinity. I always write the first part, or the negative one, on the first row. And then your f of x, what does it approach as x approaches positive infinity? So we look at our values here. We have an odd function, but we also have a negative coefficient. So that means that our graph is going to end up, and as we go to the left, as x approaches the left, that means our y value is going to be going towards positive infinity, and it's going to be the opposite as x approaches positive infinity. So this means that your f of x will approach negative infinity. So keep in mind that your x values, this part is always written the same, this part's always written the same. You just leave a couple blanks for your f of x's, and then that's the only thing that's going to change. But they are always opposite. One's negative, one's positive, one's negative, depending if you have an odd degree.